In an exam, always use the shortcut method when you're dividing fractions. It is faster, it is efficient. Now, in one of my previous videos, I talked about the standard numbers, 1, 2, your counting numbers, 3, 4, 5, 6, and yeah. And I mentioned that, really, though it is not written, this is what they are if you were to present them in fraction format. The bottom number tells you how many of what you're counting it makes a complete one of something. Alright? So if we were to have 6 divided by 3, and we know that the answer is 2. Now look at this as a shortcut, demonstrating that the shortcut method works. Okay, the shortcut method, change that to multiply, turn that one upside down, and you end up with 6 times 1 all over 1 times 3, which is equal to 6 over 3. Now if I come along there, there's your 6 over 3, divide that by 3, divide that by 3, and we get 3 divided by 3 is 1, 6 divided by 3 is 2. Think about that for a minute. Okay, so you get this here, so we can do the same thing with a fraction. If we have 3/5, want to divide that by 2/9, I'm not going to actually work it out. That becomes 3/5 multiplied by 9 over 2. Okay, it's as straightforward as that. Then you have to simplify your numbers. Coming to this for a minute. Now, let me just clear this lot away. Okay, we had 2 over 1. The top number is in ratio to the bottom number. If I multiply the top by 2, multiply the bottom by 2, it's just the same as multiplying by 1, and that would give me 4 to 2. The ratio is the same there to there. Now it's very important, the fact that this is 1. There's a cross link here to another thing to do with ratios. And think of miles per hour. They tend to write that in books simply because the people who do the printing, it's easier for them. Really, it is miles over the count of hours. So if we have 1 hour and we have 2 miles, we are doing 2 miles in 1 hour. See, there's a cross link there between fraction format and ratio, in that we use some of the properties of fractions, but this is not really a fraction per se. It is all to do with working things out. Right, I'm going to come away from that and go back to fractions proper. Okay, 2 over 7, French 7, divide that by 3 over 14. Now I used to say, until I really thought about it in depth, I used to say you cannot directly divide the top numbers unless the bottom numbers are the same. Well, in a sense that's correct, But I've heard people say you cannot do this. Alright, watch what I do. I used to think you can't do that. Wrong, you can, but the numbers sometimes are quite, you need to think a lot about them and do a lot of fiddling about, okay? So it is better that you don't do that. It does work, it does work. I don't want to go there at the moment with that and demonstrating that it does work, but trust me, that does work, but it's awkward. Shortcut method, use the use the shortcut method. So we have 2 over 7 multiplied by, turn this one upside down, 14 over 3. Now that gives me, draw my line, 2 times 14, 7 times 3. Now we can swap these things round, you know, like 2 times 4 gives 8. You can swap those around. 4 times 2 equals 8. For multiply, you can just swap the things around. It doesn't matter. So I'm going to put the 2 times the 14 on the top, and I'm going to swap the bottom ones round. I'm going to put the 3 there, and I'm going to put the 7 there. Now again, once I've done that, I can split it. I can go 2 over 3 times 14 over 7. Well, this becomes 2 over 3. 7, there's 2 7s in 14, so I can do that. If I multiply, divide that by 7 and divide that by 7, I get 2 over 1. Multiply them together. 2 times 2 is 4. 1 times 3 is 3. It does work. Okay, I've shown a lot of the steps. A great many of these steps, once you practice, you'll do in your head. You will jump steps. Now, that's the shortcut method. What the shortcut method is doing, it's actually changing that one into 4 over 14. It's converting it such that the bottom numbers are the same. The shortcut method converts that, but it does it all in one go. So you then end up with 3 over 14. Once these are the same, you're directly dividing this into that, so you end up with 4 over 3. Okay, that's what the shortcut method is doing. It doesn't look as though it is, but that is what it's actually doing. Okay, so let's do it by first principles, shall we? Now I'm going to put this in a bracket. There's your 2 over 7. Closing bracket. There's your divide, and we got 3 over 14. Change the colour. Now if I multiply that by 1, I don't change anything, but 1 comes in many forms. So in fact I could, instead of writing 1, I could write 2 over 2, which is what I'm going to do here. I'm going to rub that out, and I'm going to multiply that by, I would need to, 2 over 2, which is exactly the same as multiplying by 1, right? So we end up with, I can get rid of, no, yeah, I'll get rid of the brackets now. Let's do this line. Oh, wrong colour. Put my line there when it works. 2 times 2 is 4. I'll write it. No, I'll write it. all in one go. We've got 2 times 2, 7 times 2, there's your divide, 3 over 14. 2 times 2 is 4. 2 times 7 is 14. There's your divide, that divide there, 3 over 14. Because these numbers here are the same, this will give you exactly the same answer as if you do 4 divided by 3. Believe me, it will. You can forget about those now. It's just 4 divided by 3. And that will give me, well, a number that's decimal, or I'm going to write it as 4 over 3. Alright, that is your answer there, instead of 1 1/3. Okay, you make the bottom numbers the same. Once you've done that, you can directly divide the 3 into the answer there of this conversion. There's your conversion. Directly divide the 3 into your conversion and you get your answer. Shortcut method is doing this. Suppose we have fractions where the bottom numbers, size indicators, denominators, one will not divide exactly into another. You know, for example, if I had 1/3 divided by 2/9, the 3 will divide exactly into that, so we can share it. 9. 3 times 2, no, 3 times 3 is 9. 1 times 3 is 3, divided by 2, and that is your answer. See, look, there's your third, and if I multiply that by 3 and multiply that by 3, I end up with 3 over 9, which is what I did just now. I jumped steps. That is that. Okay, so suppose we're the situation where the one will not divide exactly into the other. Suppose we had, what should we go for? Let's go for 16 over 7. Divide that by 2/3. 3 will not divide exactly into 7. One technique is you either know a number that will both divide into exactly, or you multiply those together. You know, 3 times 7 is equal to 21. So I am choosing to have fractions where the bottom number is 21. Okay, let's look at, and let's use my brackets. You know, they just group things. They don't do anything other than group things. Change color. Now I want a number there at the bottom, 21. If I multiply that by 3, I get 21. Multiply the bottom by 3, I have to multiply the top by 3. Okay, so that has done that one there. There's the divide, and we come down here and we have our 2/3. Now again, I want the bottom number, the size indicator, to be 21. Now if I multiply that by 7, so what I've done is I've multiplied these two together to give me the 21. Right? Multiply the bottom by 7, multiply the top by 7, which is the equivalent of multiplying the whole thing by 1. Notice I use the word equivalent. Now 16 times 3, 3, 6, 18, 48. 3 times 7, 21. There's your divide. 2 times 7 is 14. 3 times 7 is 21. Now the bottom numbers are the same. size indicators, so we can do away with those if you like and just write 48 divided by 14. Writing that in fraction form, I get 48 over 14. Now this will simplify a bit. Notice they're both even numbers. So if I divide the top by 2, I divide the bottom by 2, I keep the ratio. See the ratio, they crop up all over the place, these things. Half of that is 24. Half of that is 7. 7 is a prime number. You won't get that down any further. You know, if you like, 3 times 7 equals 21, so it is 3. 21 from 24 gives me 3 over 7, if you want to write it that way. It is a sort of cheat, multiplying those two numbers together. You don't always have to do that. Now, okay, this is live. Here we go. And yeah, let's do it. Oh, I wanted it as images. Here we go. You get lots of different things to do with divisibility, rules of divisibility. You know, if it's divisible by 2, it's these rules. It's a case of memory, really, and practice. If you're one of these people that no matter how hard you try, you can't remember, you're going to have to find your own way of getting round it. But these are very useful to know. There are some that go up even higher than 10. Be careful when you're downloading these. I had a go at one a little while ago and my virus scanner said, oops, risk, don't open it. Right, so be careful about downloading stuff like this.